Good evening, everyone, or good morning or good afternoon, depending where you're located. And welcome for another JavaScript marathon. This time we're going to talk about unit testing with NgRx. First, my name is Frederik Prijk. I'm a senior software engineer at this.labs. You can find me on Twitter using the handle mentioned at the bottom of the screen. And please don't hesitate if you have any questions, feedbacks, or concerns. Of course, we couldn't do all of this without our sponsors. Our first sponsor for today is this.labs. We are your partner in modern digital transformation. We specialize in mentorship, consulting, training, and staff augmentation for enterprise organizations. You can find more at this.labs.com, or you can send us an email at hi@this.co. If you're also having trouble keeping up with the constant evolving technologies, and you want to bring your team up to speed with one of the latest technologies, well, this.labs offers personalized training programs to suit your organizational needs, ensuring you and your company stay up to date on the leading edge. You can contact us again at hi@this.co to set up your complementary needs assessment. Apart from this JavaScript marathon, we also have our online meetups. And one of them is the Angular meetup, which is always hosted the first Thursday of the month. The next one will be May the 7th, and which will be about the state of NgRx. Basically, this is a partnership with Narwhal, and we will have Brandon Roberts, Wes Grimes, Mike Ryan, and Alex Okrushko from the NgRx core team speaking about the state of NgRx. You can register on angularmeetup.com. We also have a React meetup, which is the second Thursday of the month, and the next one will be about the state of React with some of the React core team members. And also a Vue meetup, also online, which will be the third Thursday of the month, and you can register on vuemeetup.com. Our next sponsor for today is Infragistics. You can learn how to build better, faster Angular apps with Ignite UI. There are hundreds of ready-to-use templates, Angular components, charts, and controls to make your development experience positive. Ignite UI is a developer's choice for Angular, and you can check out our sample apps and try Ignite UI for Angular for free at the link mentioned at the screen. And other than that, Infragistics is also doing a giveaway. So give us your favorite thing about this session and tweet to @this.media and @Infragistics with the hashtag JavaScript Marathon, and get a chance to win a 1-year license for Ignite UI for Angular. All right, unit testing with NgRx. So today we're going to talk about how we can unit test some parts of NgRx, such as reducers, selectors, effects, and components that are making use of the store. We are not going to go into details of how we set up NgRx and stuff like that. So we're going to start from an existing NgRx application, which I will give you an overview of, and then we will dive into testing it. So first things first, how does the application look like that we are going to work with? So basically, if anyone attended my previous session, that was also about TV shows. This one is again about TV shows, and basically we'll have an application that has an all shows and a favorite shows section. We can favorite shows by clicking favorite, and they will show up in the favorite shows section, and we can click unfavorite, and they will be removed from the favorite shows section. We can also remove them, and then the show is removed. This is a very simple application, and it's using the NgRx store to manage all the actions and the state and stuff like that. So the idea is now to write unit tests for all of the different NgRx stuff. Of course, there's also integration testing. So we can argue about whether or not we want to unit test the store or we want to do some more integration testing. I don't want to go into details into that today. The idea of today is to show you how you can unit test every aspect separately And I feel it's still up to you whether or not you want to unit test everything separately, or you want to go for a more integration testing, testing different parts of NgRx at the same time. So first things first, I showed you how the application looked like from a user perspective. So let's dive into the code and see what we have before we write some tests. I'm going to ensure my font is big enough. So our application consists of only a few components. In this case, we have the all shows component and we have the favorite shows component. Both components are responsible for rendering the corresponding page. And as you can see, so the all shows component is using the store to retrieve the shows, all the shows, and is dispatching the corresponding actions to favorite, unfavorite, and remove the show. Just calling store.dispatch with the appropriate actions. Favorite show is doing the exact same thing. It's using also an observable to retrieve the favorite shows, in this case, from the store, and dispatching 3 different actions. We could argue that this is the exact same code, so we could probably avoid duplicating it, but for the sake of this demo, I have separated the code, which will be more clear why I did that when we dive into the testing. There's also a reusable DOM component for the visualization of the shows, but that's not relevant for NgRx. That's entirely decoupled from NgRx. Then the most important part is everything that's NgRx. So we have an actions file, and the actions file is going to represent all the actions that we will be dispatching through our application. So first of all, we want to know whenever the application is loaded, because we want to retrieve some initial data whenever the application is loaded. Whenever we retrieve that data, we're going to dispatch a get all success action and a get all failed, potentially, if something went wrong. Sorry, we also have the all shows actions, which is an object that contains 3 properties. One that contains the favorite show clicked action, the unfavorite show clicked action, and the remove show clicked action. Those are, of course, the ones that we were dispatching from our component whenever the user clicks the corresponding button. These are the actions for the all shows, and then we have the same actions for the favorite shows. So we have the same actions, but the actions define where they are dispatched from. So in this case, we know that the show is favorited from the favorite shows page, and here we know it was favorited from the all shows page. And then, because clicking a button or favoriting, unfavoriting a show is actually an HTTP call, we also have the corresponding success actions. And normally we also have the corresponding failed actions, but in this demo, we are not really handling errors, which you probably would or should do in your application. So other than the actions, we have reducer. Reducer is responsible for keeping track of our state. We have 4 actions that we are handling. So get all success basically sets all the shows. The payload contains a shows array, and it's going to update the store with all the shows. It's going to override everything. It's not going to concatenate anything. It's just going to take what it retrieves and puts it in the store. Favorite show success will basically update the show based on the show ID and set the isFavorite property to true, while unfavorite show sets the isFavorite show property to false. And remove show success will just filter the array and ensure that we return a new array that doesn't contain the show that we have removed. So this is the reducer. And of course, we have a selector. So NgRx has the ability to create selectors, which allow you to actually select subsets of your store. So our store contains all of the shows as a single array, but we want to be able to, at some point, retrieve only the favorite shows. For that, we can create a selector that is basically using all the shows and is only retrieving those that have isFavorite set to true. And this is using the create selector. So we have actions, reducers, and selectors. And last but not least, we have the effects. Effects are the most complex part of the demo, both from the code itself as for the unit tests. I think it's very interesting how we can unit test effects. I think it's very easy once you understand how you can test it, depending on the complexity of your effect itself, of course. So as I said, whenever the application loads, we want to retrieve all the shows through the service, map it to a get all success action, which will be handled by the reducer and update to store. As you can see, I'm not handling any error case in this reducer, in this effect, sorry, again, which you probably should. Then we have favorite show, which is also an effect that's, in this case, listening to two actions. The favorite show clicked for the all shows, and the favorite show clicked for the favorite shows. Whenever one of those actions is dispatched, we are calling the favorite show on our show service and map it to a favorite show success action. In this case, we are handling the errors. Well, you can call, well, it's not really handling, but we are ensuring the observable doesn't break, but you probably want to do more than just returning off null. Unfavorite show is doing the exact same thing, but it's calling the unfavorite show on the show service and mapping it to an unfavorite show success action. A remove show is calling the remove show on the show service and mapping it to a remove show success. This is the effect. So the last part that we have is the show service, which theoretically is a service that does an HTTP call. In this case, it is just using internal arrays and stuff like that to make it easier for this demo. But again, this is not something we will be testing. Testing a service is not related to NgRx, so we will focus on everything for NgRx. The first thing I want to test is the reducer. A reducer, let me close the rest. A reducer is actually just a function. It's a pure function that retrieves two arguments. If you can see here, a reducer is a function that retrieves the state and an action, and it's going to return the updated state. That's basically what a reducer does. Simple function, you give it a state, an action, and it returns a new state. So the first, I've written the boilerplate for all my tests already. So first thing I want to test is that my reducer doesn't handle an action that it doesn't know. That's the first thing you want to do. So for that, I'm going to create an action that we shouldn't be handling. Let's call it an action with type unknown. This is something that isn't registered to our reducer, and our reducer should not do anything with that. Testing a reducer is just the same as testing a simple function. So our reducer is a function that we should call with the corresponding arguments, which is, as I said, the state and the action. We don't have the state yet, so we need to create the state. There are two ways that we can create the state. We can either, for every test, create the state manually, or we can retrieve the state, initial state, from our reducer. As most reducers provide their initial state, in this case, it's an empty array, but every reducer can define its own initial state. We can use that if we want to. However, this ties the test to the initial state here. So if we would change the initial state, which is used in our application, that might break our test. So you can decide to do that or to not do that. That's up to you. So then we can call that function with the initial state and the action, and it returns the new state. Then what we want to expect is that the state is the same as the initial state. By using to-be, we are both actually checking that the values are the same. Well, we are actually just checking that the reference is the same. We could use to equal. To equal only checks the properties. In this case, we want to ensure that nothing has changed. So also the reference shouldn't have been changed. So we can do to-be. We can save it, and our test should run again, and this should succeed. We have 25 success tests, but of course, every other test is successful because I don't have any expectations. But this test is now running successfully. So what do we do to test a reducer? We build up the state, so the state that is being sent to the reducer, and the action that the reducer should or should not handle. And then we basically do an expectation on the return value and see if the modifications to the state have been happened. In this case, we don't expect any modifications, so we verify that that's the case. So this is interesting, but it gets more interesting as soon as we start testing actual state updates. So the next thing is we want to test if it updates the state whenever a get all success action is dispatched. So in this case, we need in this case, I'm sorry, we need to call the reducer again, which is going to be the exact same code as here. This is going to be identical all the time. So we're going to call the reducer with our initial state and with our action. In this case, our action is the get all success action, right? So we want to verify that the reducer handles the get all success action. The get all success action expects a shows array, so a new state. So we have the initial state, which is the state before sending the action, and we have the new state, which is actually the payload for our action. So in this case, the new state should be an array of shows. So I just pass it, create a new state object or array that contains one show. And I'm sending that action to my reducer. And then basically I want to expect that the state is equal to the new state, right? So you want to ensure that the state that we retrieve from our reducer is the same as the values or the array that we send in. And then probably you also want to guarantee that it's immutable. So it shouldn't be the same reference, right? So you want the state to have the same values, but you want to ensure that it's wrapped in a new object. So that it's always, whenever we send something as part of an action to the store, that the store ensures that it's updating the state immutable. So there was a valid point about the fact that the properties, the reference could be the same, but the properties can be mutated. True. Sure. So of course, you can decide whatever expectations that you do on your tests. So in this case, we could add in two equal. So you want to ensure it's the same reference, but it also has the same properties. You can start comparing properties by properties. You can create your expectations the way you want. Of course, for every test there will be multiple expectations that you can do, but it's a valid point that in this case we could have the same reference, but we could be updating the state, which is also something that we want to be careful from, because you don't want to do mutable changes in your reducer. So it's a valid comment from Georgie that you want to ensure that you also do not change any properties in this case. But this is of course the case for every test that we are going to write for a reducer. You want to ensure that it only change the properties that you expect it to change, which is not something we are going to focus on for the other tests. We are going to focus on everything we expect to have changed. But of course, you might want to add other tests that ensure that it doesn't change anything you didn't expect that it changed. Okay, so sorry, back to this test. So the get all success action should be dispatched with a new state. It should pass that action to the reducer together with the initial state that returns a new state, and then we can check that it's equal but not the same. So the properties are the same, but it's not the same reference. This is actually guaranteeing that in this case we are creating a new array. In case we would do this, this would actually break our test, because in this case it's not a new instance, right? We have one fail. Okay. So the next thing we want to do is we want to ensure that it handles the favorite show success action, which is going to be comparable as well, right? So we want to call the reducer. Right? But in this case, we want to call it with a favorite show success action. So we create our action, which is the one that we are going to dispatch to the store. So whenever a show has been successfully favorited, we create a favorite show success action, pass it to appropriate payload, which in this case is show ID 1, and we send that action to our reducer. Our reducer also needs an initial state, which in this case, I'm now creating my initial state myself. I'm not using the initial state from the reducer anymore, because I really want to take control of my initial state, so that I know which state I have before sending my actions, which is actually, in my opinion, a better idea, because it keeps your tests decoupled from your initial state in your reducer. So whenever we have this state, which has an ID of 1 and is favorite false, and we send the favorite show success for show ID 1 to the store, we expect that the state still has one item whose favorite property is going to be true. Then we know that whenever the favorite show success action is being dispatched to the store, the movie or the TV show in the store, that its favorite property is updated to true. Of course, if we want, we can add. We can add another show of ID 2, which is its favorite false, and guarantee that in this case the second show favorite property is untouched, is still false. All right. So whenever a favorite show success action with a specific show ID that matches a show in the store is sent to the reducer, we know it's handled properly. However, we want to do the same thing with a show ID that doesn't exist. So in this case, we have an initial state with an ID 1, and we have a favorite show success with a show ID of 2. This means that this show ID doesn't exist in our store. So in that case, we want to guarantee that it doesn't touch our state, right? This isn't the most useful test, I would argue, but this tests that whenever it doesn't find anything in the store, that it doesn't really touch the store. Well, it does touch the store in this case. It will create a new array, but it will not change any property, right? So in this case, the state, we can do not to be the initial state, right? Then we guarantee that it's a new reference, which is or isn't something you might want in this case, right? Because whenever it didn't find anything, why would we want another state? So in this case, we could decide to remove that and update our reducer to ensure that it doesn't touch the store in case it doesn't find an ID. It will make your reducer a little bit more complex, but writing tests this way also finds bugs or special edge cases in your reducer that you might want to change or handle differently. But as you can see, there's always the same pattern in testing reducers. You create an initial state, you create an action, you call the reducer, it returns a new state, and then you do expectations, whichever you want, right? Testing NgRx isn't really telling you what you should expect. It's more about the stuff that we are doing before up front. That is about how we can test all this stuff. So unfavored show success is going to be the exact same thing. I'm not going to go over all the tests, but in this case, for unfavored show success, when it should update the state in an immutable way. So whenever we send an unfavored show success action to the reducer, our initial state will ensure, our reducer will ensure that the initial state is updated and that the isFavorite property is set to false. Okay. And this will be the same for all other tests. I'm going to copy all of them in here, that we have all of them working. So it should not update the state when show ID should not exist. So when unfavored show success is dispatched with a show ID that we don't know, the isFavorite property is still true. Then with remove show success, we have the same things that we want to test. So whenever we dispatch the remove show success, we expect that it is removed. So in this case, we have an array of one show. We dispatch the remove show success with show ID 1. In this case, we expect that now the array is an empty array. And whenever it doesn't find the ID, we expect that the array is still an array of one item. So this is actually the pattern that you can follow to test your reducers. Of course, some reducers are more complex, involve more complex testing. But again, that's more part of how you can test your code rather than how we can test NgRx itself. So testing reducers is actually not that hard or not that special to NgRx itself. It's more like testing a function. The next thing we want to test as part of NgRx is our selectors, or are our selectors. So in this case, we have one selector, which is basically taking the shows in our store and only retrieving the shows that are marked as favorite. So we want to write a test that tests that. And that's interesting because let's get my selector. So my selector is select favorite shows. And that actually has a projector method. Projector method is part of the selector in NgRx. That actually is a method that can be used to project my selector on some kind of state. In this case, my state is an array of shows. So let's say we have an array of shows. In this case, we have an array of 2 shows, one with ID 1 that's favorite and one with ID 2 that's not favorite. This is just a simple array of shows, and we can send that or pass that to the projector method. So the selector has a projector method that takes in the state. This needs to be the same type of your state, but in my case, the state that the selector works uses is the value returned from the select shows. We're going to test the select favorite show selector, which uses the select shows, which returns an array of shows, right? So initial state has to be an array of shows, and this returns the result. So this is actually going to be the result whenever our store should contain this list of shows. And then we can expect that our result is actually has a length of 1, and that our first or our only item in our array has an ID of 1. So this works. This works again. So this is actually how you can write tests for selectors. A selector is always something that works around a given set of a given state. In this case, select shows. Right? This isn't a selector, even though I named that select shows. That's actually not the best naming. Let's call it get all shows. Because this isn't a selector, this is just an arrow function that's retrieving the shows property from the state, which is different from a selector. A selector in NgRx is something that uses create selector. And because we use create selector, you can see that this has the projector method. That's the one we are using. So let's rename this to select shows again. So this is the selector that we have and that we are using throughout our application. And this is how you can test selectors. Selectors are probably not the most fancy thing to test in your application, but it's actually pretty cool if you start using selectors extensively, that you can guarantee that it returns or it selects the portion of the state that you expect it to select, which you can do with a few simple tests that use the projector. But now the most important, most complex, maybe also the most interesting part of testing NgRx is testing effects, right? We have a few effects that are actually going to listen to an action stream. This is an effect always starts from an action stream. So we listen to the action stream, and whenever an action of a specific type that we are interested in is dispatched, then we do the effect does its thing, right? In this case, we are going to use exhaust map, and we're going to get all the shows from the service, which would be the backend, and map that to a get all success action. Again, an effect, the result of an effect is always an action, and the action will then again be dispatched. You could dispatch an action from an effect or return an action from an effect and handle that in another effect. You could do that, but you have to be careful, as was mentioned in the other talk about NgRx from my colleague Rob Osell. I think he talked about being careful with, I don't know how he named it, but the fact that you can have an effect, trigger an effect, trigger another effect, trigger yet another effect, and eventually you will lose track of whatever's happening. But in this case, get all success will be dispatched, and in this case, handled by the store. So let's write a test for this effect. But before we do that, I created some boilerplate, and I want to go over the boilerplate that we need in order to test effects. So up until now, I didn't use Angular's testbed. So Angular has a testbed that you can use to configure a testing module. For effects, I will be using that because I need to provide some things to the providers of our module, and it makes testing easier. We can test this without testbed, but I feel like using testbed for this is a lot easier. So first of all, our store will need an initial state. Again, we could retrieve the initial state from our reducer and use that here. But again, I've created something that isolates the initial state in my test from the initial state in my actual application. Then I want a show service mock. So I have a show service that is being used by the effect. As you can see, I inject a show service and it's used throughout every effect. So I need a mock version of all my methods: get all, favorite show, unfavorite show, and remove show. This is because I don't want any of the actual implementation to be executed. Then I keep track of a few things that I will need later. Of course, as we are testing our effect, which is called shows effects, I want to keep track of an instance of my effects that I'm testing. Then I want to keep track of actions, which is of type observable any, which actually is going to represent the action stream, which is going to be the stream that we are injecting in our effect and is the one that is actually used as the trigger for every single effect. We are keeping track of an instance of our action stream to ensure that we can manipulate that stream, because as that is the trigger for every effect, it might make sense that we need that action stream to manipulate that action stream in order to be able to test some things, right? We want to send something through that action stream and verify what has happened. And then I want to keep track of the store, which is of type mock store. We are not using the store type, we are using the mock store type, which is a little variant of the store, allowing us to do a little bit more than what we can do with store, but more on that later. And we are going to use the test scheduler, but I will explain that later. That's part of RxJS testing, which I will explain not deeply, but I touch it slightly a little bit later. But I will need an instance of a test scheduler. So first, I create a test. I configure a testing module, and I specify a few providers. So my shows effect, a not mocked version. This is my actual class. Then I ensure that I mock my store. So NgRx has a provide mock store function that we can call with our initial state. So this ensures that NgRx is set up in a mocked state, right? This doesn't register a full-blown store. This registers whatever we need for mocking the store. And I want to use provide mock actions, which is also from NgRx. Let me see, which is from NgRx effects. Provide mock actions is from effects, which actually allows us to register a callback. So this is a callback. So this is a function that returns the observable that we created here, right? So this allows us to manipulate the action stream that we will use here, right? So NgRx is going to use this callback and call it, then use the actions that is returned from that arrow function as a source for its action stream. I hope it'll get clearer later. And then last but not least, we want to register our shows service mock. Then this is a nice way to retrieve the instance of our registered services. So we can do effects equals testbed.inject shows effects, which retrieves the instance, the shows effects instance that is registered with our Angular testbed module. Same with store. We want to keep track of the instance of the mock store. And then something interesting. The mock store is as I said, is a special type of NgRx store, which has a few extra methods. Such as set state. So the mock store is actually the mock store allows us to set the state instead of dispatching actions, right? If you would just register the store, you could dispatch actions until the store is in a way that you expected and then write some tests. But instead, we can just use our mock store and call store.setState and set the store in a state that we want. We can do this in a before each, or we can do this on a per test basis, right? We can, for every test, we can update or override the state and ensure that the state is in that the store state is in a state that we expect. That's a weird sentence, but yeah, I get it. I hope you get it. So this ensures that our store is set to an empty array, which is actually useless. Sorry. That's also my initial state. So there's no need for me to set the state to the same thing as the initial state, because that's already happened by calling provide mock store, but sure. And then we have test scheduler. Here's a link. As was asked in that comment thread, yes, you can get access to the demo, to the code after this session. Follow me on Twitter or read my Twitter if you don't want to follow me. And I will tweet out the link to the source code. So the test scheduler, there's a link to RxJS documentation that explains everything about the test scheduler, but that's basically something we can use to execute our effects in a synchronous manner. We need to do this, so we need to assign a test scheduler to a new test scheduler and expect the actual to equal expected. I'm not an expert in whatever is happening here. The documentation that we have here, which I can show you, just so that you know that I am not making this up. You will see that the documentation for RxJS is talking about the test scheduler. And the first thing that you need to do is write something that does the assertion for you to expect that something is equal. You can do more, right? You can do a deep equal. You can do an equal. You have totally control of whether or not to define how something is considered equal or not equal. But this is an interesting page if you want to dig into what test scheduler is about. So first test should be created. You can ignore that. But the first thing we want to write is get all shows should handle the uploaded event and return a get all success action. So that means that whenever uploaded is being emitted as part of the action stream, we expect that this effect returns a get all success action. That's what we want to test. So to do that, it's going to be a little bit more complex. But we start with defining the triggers of our effect. So the first thing is we want to have an action that is going to be dispatched. So we want to have the app loaded action. So it's going to be the trigger. And we want to have the outcome of our effect, right? So the outcome is going to be a get all success action. And it's going to contain a shows array. I need to learn how to type. So we need to define a shows array that is going to be the actual, let's call it the response of our HTTP call. Our HTTP call is going to return an array of shows. So let me steal some shows like this. So now we have an array of shows. So we have an action, which is the uploaded action that does not have any arguments. And we have the outcome, which is of type get all success, which has an array of one show. All right. The next thing we need to do is now we need to use the test scheduler. The test scheduler has a run function, and the run function is called with an object that has a few properties. Right. So we have a, oh, not run. We have a hot, cold, expect, and expect observable. Again, I'm not an expert in test scheduler, but basically by using hot and cold, we can create hot and cold observables. The difference between a hot and a cold observable, sorry if I'm wrong here, but I think hot observable basically means that if you didn't subscribe in time, you will miss it. And a cold basically means whenever you subscribe, you get the entire emission of items again. I always explain it as if you're watching a movie. If you watch a movie at home, sorry, if you go to the theater and you run late, you miss the beginning of the movie, right? The movie is not going to wait for you. So that's a hot observable. But if you're watching a movie with a friend and you're going to be late, and you call your friend that you're going to be late, the friend can wait and start to show whenever you arrive. That's more like a cold observable, right? So a hot observable is if you subscribe whenever after an event has been emitted, you won't get that event anymore. And a cold, whenever you subscribe after the event has been emitted, you will still get that or all emits of that observable. But again, I'm not an expert in hot versus cold observables. And then we can use expect observable to do the expectations. All right. So now the first thing we want to do is we want to create our action stream. Our action stream is going to be a hot observable. And now we need to use some marble diagrams. This is going to be a little bit tricky, and I'm going to explain that. But a marble diagram is actually something, let me write some comments, is actually something that, so an observable is something that emits items over time, right? And marble diagram is actually something that visualizes that emission over time. So let's say every dash that I have here is 10 milliseconds. And we can decide that, let's say we have 1, 2, 3, 4, 5, 6 dashes. That means 6 milliseconds or 60 milliseconds. And we can define that after 10 milliseconds, it has to emit A. And after another 10 milliseconds, it has to emit B. This is very cryptic, but this allows us to control the observable that's emitting items over time, right? But then you can ask yourself, but what does A mean? There's a second argument that we can use to define what the values are. So we can call this B, and then we need to ensure that this is called B as well. So actually this object is used to map the values we have here to the actual action that we have defined here. So if we would look again, basically we are creating an observable here that's emitting an action, the app loaded action, on the second tick. Right, so this is actually implementing something asynchronously. We could remove this dash in the beginning, and then we would just have a stream that immediately emits the action. But for the purpose of this demo, let's add a dash, and an extra frame is what it's being called in marble testing. So now we actually have our action stream, which is our stream that's being used here. Right, the action stream. And we know that this action stream will be an observable that will eventually, not instantly, but eventually emit the app loaded action. Of course, our effect is using a service. And it's using the value returned from that service, which is called the shows. It's using the value returned from that service and passes that to the get all success. That means that the shows array that we are here expecting in our get all success action, we need to have that being returned from our get all method. To do that, we can do the following. So we can create a response, which is also going to be an observable. In this case, it's going to be a cold observable that is going to return our outcome, our shows. Right. So this is using the cold function that we get from the test scheduler. This is going to create an observable. Again, 2 ticks, 10 milliseconds, another 10 milliseconds, and after 10 milliseconds, it's going to emit the shows array that we have here. And then we can basically set up our show service to ensure that our get all method returns the response. So now our show service.getAll is configured to return an observable that is emitting the shows in an asynchronous manner again, right? And of course, it will also complete. So by using marble diagrams, when we use a pipe, we basically tell the observable it completes. And then the last thing we have to do is we have to expect. So we can use expect observable, which is a different expect than what we had in our other tests. We can use expect observables instead of expect, and then we need to use our effect. In this case, we are testing the get all shows effect, and you want it to be equal to another marble diagram, right? So now we need to figure out what marble diagram our effect is going to be. So we start from an action stream that is emitting a value or action uploaded after 2 ticks. After 2 ticks, it will map that value to another observable that emits a value after 2 ticks again, right? So this means that actually our value B, which will be our outcome, will be emitted after 3 ticks, right? Because actually you need to see the observables. You can see them below each other. This is how you should see it. Whenever A emits, the other observable is triggered, but the other observable does not instantly return something. It also starts with an empty tick, and then it returns B. So that means that if you would take the combination, you would only get B after the 3rd tick. Not the 4th, not the 2nd, the 3rd tick. Marble diagrams is a little bit tricky, but it's very important if you want to test your observables, your effects, without doing some kind of subscriptions or anything else. So now we know that after 3 ticks, it will emit B, and B will be our outcome, where outcome is our action of type getAllSuccess. Right? So if we would save our code now, we would still have 25 successful tests. Just to verify, if we would add another tick, our test should fail. So it does fail. So now we know that our test works. So by using test scheduler, everything is run synchronously. We don't have to worry about asynchronity. We don't have to call anything like tick or L, anything. This is actually the general pattern how we write an effect, right? So we write a test for an effect. So we start with the action that we want to dispatch as part of the action stream. We define the outcome, which is the returned action of our stream. And then we run the test scheduler, which creates the action stream. And funny, this is in all my tests that I have for this session, this line is going to be identical because we define an action and our action stream is always going to emit that action. In my case, always on the 2nd tick. You can decide maybe some effects require another tick. Not sure why, but maybe that's going to be the case in your application. But in this demo, this will be identical. We always need to create a response. The response will not always be the same. We're not always calling get all. Sometimes we're calling favorite show, unfavorite show, or whatever. And we always need to do an expectation. So let's go over to the 2nd test and see what we need for that. I'm not going to write it all by hand, but I'll go over it again. So we start with creating the action that triggers our effect. So let me open the favorite show effect, which in this case listens to the action stream. And whenever favorite show clicked is emitted, it's going to kick off. So in this case, we register a favorite show clicked with a specific show ID. In this case, the show ID is equal to 1. And then the outcome is the favorite show success action. If you would open our effect, you would see that our effect returns a favorite show success action whenever everything happens successfully. Then again, we use our test scheduler. We define our action stream, as I said, identical to what we had before. We define our response, which is identical to what we had before. However, in this case, I don't care about the response of our service. Our service favorite shows returns something here. I don't care what it returns. As long as it's successful, I already know the show ID, and that's all I need to update my store. So that's why in this case, I use A, but I could use null, whatever. A wasn't really the most ideal value, I guess. So now we have the exact same kind of response, but in this case, we use showService.favoriteShow and mock that to return our response. And then again, expect our favorite show effect to be equal to --b, where b is our outcome. And you will see that again, this is successful. So would it be the same to write hot A and cold B and expect -b? So you can drop this, you can drop this, and then you can drop this. That's what we're asking, and that should also work. Let's that's interesting. Should that also work? There is no, because there is no empty tick, I guess there is no asynchronity, right? Yeah, because if we would write that out, you would have A, but you would have instant B. So yeah, because previously, if we write that tick A, that means that here we have tick B, and that means that now we have tick B, right? A emits, and that kicks off the other observer, but the other observer is an empty tick B, which results in 2 ticks. But if we have A and B without an empty tick, the result is instantly B and not dash B. Yeah, this is how we can test favorite show. For Funzy, let's also do unfavorite show, but really, this is going to be exactly the same again. We have our show ID of 1. We have our actions.unfavorite show clicked, which is again the trigger for our unfavorite show effect. And this is our action. Then we have our outcome, which is unfavorite show success action with our same show ID. We have our test scheduler, our action stream, our response stream, and we set up our show service.unfavorite shows mock and have it return response, and then expect the other effect now, unfavorite show, to be dash dash B, where B is outcome. And now this should also work. So this is how you can write effects. There's still one more to go, but I would also like to end with testing a component instead of only effects. But this is actually the pattern to test effects, which is in a lot of applications, this code is really identical. So let's move over to the favorite shows components. Well, the test file, of course. So the favorite show has a few things that we want to test. I'm not going to try and rush this, but I am going to try and finish it. So the favorite show is doing 2 things. The component, it's either dispatching the corresponding action to the store, and it's using the selector to update the UI. So I've created some boilerplate to set up my tests. This is normal boilerplate to test the component. You get a fixture, a component. We want to use the mock store again. I have some initial state that I want to use throughout my tests. Then I have my for each to configure my test bed. In this case, I'm using Angular materials, so I need some material modules. I'm using a provide mock store because I'm not using effects. I don't need to use provide mock actions in this case. And I need my declarations for the components that I'm testing, which is the favorite shows component and the shows component. The shows component is the dump component that I mentioned. That is not really part of whatever we are doing with NgRx. Then I need to keep track of all my instances that I want to track, and I call fixture.detect changes. Then I'm also spying on the store.dispatch and call fake because I don't care what's happening whenever we call dispatch. I just want to ensure that it dispatches favorite show clicked whenever we call favorite show on our components. And actually, this is all we have to do is call this. So we call the favorite show on our component. So we provide it with a show ID of 1, and we can call favorite show with show ID of 1, and then we know that it should call our favorite shows action. Our store.dispatch should have been called with the favorite show clicked action. This is a simple test. This is just ensuring that whenever we call the component.favorite show, that the action is being dispatched. You could take this one step further and actually click the button using Angular testing and expect that the service has been called. I don't have that in my demo, but that is actually just the same as you would test any other click event in Angular and then expect that the store dispatch has been called with the correct value. So the unfavorite and remove show are identical. And then I want to add one more thing to my demo that I think is very interesting to know, and that is whenever your component, in this case favorite shows, is using a selector. We have something cool in NgRx that allows us to modify that selector, because a selector is actually a subset of your store. So in order to test that selector, you could set up the entire store to satisfy that selector. But if you have the very, very complex selector that combines a lot of stuff from your store, you will have a lot of code to set up your store. Instead, there is something in NgRx that allows us to override our selector for our test, right? We don't want to test our selector in this case. We have already validated in our other tests, in our selector test, that the selector selects the correct value from our store. Now we want to test that our component renders the correct stuff based on our selector. We don't care about whether or not the selector works. But this is the point where you could argue, well, maybe we do care and we don't want to unit test everything, but we want to write an integration test instead. A valid point, you can go with that. But I do want to show you that you can also unit test and mock your selectors by calling store.override selector. So store is in this case the instance of mock store, and you can call it override selector. The first argument is your selector. So if you would click it, you would see this takes me to my selector. The second argument is the value for that selector. And then you can call fixture.detect changes. Then we want to test that it renders all my favorite shows. This is not really relevant, but if you would open shows.component.html, you would see that every show is a mat card. So if we would have multiple shows, we would have multiple mat card components. So in order to verify that a number of shows are rendered, I'm basically using fixture.debugelement.queryAll, and I query my elements by CSS by selecting the .mat card and actually just counting how many mat cards are rendered, which in this case is 1. Right. So this works, and then we know that whenever our selector has a certain value, our UI reflects those values. Well, we should also test the name and description, which we can now do if we want to. But other than that, there is something more to testing selectors. And that is that you can set a selector. So the store.override selector returns a mock selector. And a mock selector is of type, honestly, I have no idea what type it is, memwise selector apparently. That has a method setResult. And setResult is actually something that you can use to update the result of that selector for a specific test. So now you can say that that same selector, in the first test, it has a length of 1. But in this case, we are updating that selector to return an array of 2 items. Then we call store.refreshState and fixture.detect changes. Store.refreshState is a method on mock store, again, not on the actual store, but on the mock store. And then we can just guarantee or query the debug element by mat cards again and expect that the length is now 2. If you would save this, you would see that you now have 2 mat cards and that all my tests are working. And this is how you can mock selectors and how you can unit test components that are using selectors and are using store.dispatch without a lot of complexity of the store. If you would do a really integration test and you want to set up the entire store, it can get really complex. I've also worked on projects where we set up a lot of dispatches to the store and before eaches to ensure that the store is in a specific state, while actually if you use selectors, that's not necessary. This is basically what I wanted to talk about NgRx as part of this demo. As I've mentioned before, the source code will be available on GitHub, and I will tweet that after my demo. It will take an hour or something, but I'll tweet the link so you can get the source code, play around with it, and please feel free to ask any questions. Ping me on Twitter about how we can achieve anything, or if you have any questions. And keep in mind, if you find this training helpful and you would like to learn more, please let us know. We would love to teach you more because this.labs is also offering virtual corporate trainings. So on that note, I would like to thank all of you for attending and have a great rest of the day.